Good morning, my dear students. It gives me great pleasure to talk to a student through video presentations like this as usual. Just share the videos with your friends. You can advise your friends to subscribe by clicking the subscribe button as well as the bell icon. Subscription has no charges. The very idea of subscription is to get automatic notification about new videos being uploaded in the channel. I hope all the videos are useful to you and for better share with your friends. Now, this video presentation deals with section B of model paper 2 of class 12 of term 2. First question meant for today goes like this. This is the seventh question. Solve x square plus 1 into dy minus 2xy dx is equal to 0, and you are given y is equal to 1 when x is equal to 1. When such a condition is given, you mean to say you are required to find the particular solution. That is the meaning. Let me just start with the answer now. X square plus 1 times dy minus 2xy times dx is equal to 0. Let me just move a little bit. Okay. Here you mean to say x square plus 1 times dy is equal to 2xy times dx, which implies integral dy by y is equal to integral 2x dx by x square plus 1. This is nothing but log y is equal to integral du by u, where my u is the denominator in the right hand side. Therefore, which will imply you log y is equal to log u plus log c, which implies log y is equal to log cu, which implies y is equal to cu, implies y is equal to c into x square plus 1 is the required. This is the required general solution. If you write the solution with respect to c, the constant of integration, as it is called the general solution. When x is equal to 1, y is equal to 1, this is the condition given to you. Therefore, I mean to say 1 is equal to c into 1 plus 1, implies c is equal to half, implies y, therefore y is equal to x square plus 1 by 2, or 2y is equal to x square plus 1 is this is the required particular solution. Once you are able to get the particular value for c, it is called the particular solution. That is known as the particular solution. That is known as the particular solution. Let me just repeat the whole answer again. Just see here, solve x square plus 1 times dy minus 2xy times dx equal to 0. Now for x square plus 1 dy is equal to 2xy dx. Now for it comes under variable separable format. Bring y down, integral dy by y. Bring x square plus 1 down here. Derivative of y is dy, x square plus 1 is 2x dx. Now for this can be written as log y directly. Here I write as du by u, where u is the denominator, x square plus 1 here. Log y is equal to log u plus log c. Log y is log cu by product rule of logarithms. We should not cancel log. Remember carefully. We should not cancel out log. We are supposed to just equate the quantities. We should not cancel out log. Remember carefully. For y is equal to cu. Y is equal to c into x square plus 1 is the required general solution. If I give the solution in terms of c as it is, which is known as the constant of integration, which is called general solution. To get the particular value of c, you are given the condition when x is 1, y is 1. 1 is equal to c into 1 plus 1, c becomes half. Now for y is equal to x square plus 1 by 2, or 2y equal to x square plus 1, that is known as the particular solution. That is called the particular solution. I hope it is easier for anybody to follow. It's a problem which comes under variable separable format. If I am able to separate the variables and integrate both sides, and if I am able to get the solution, it is called variable separable method in differential equations. Okay, that method is called variable separable method. Okay, next problem goes like this. See here, this is your 8th problem in the same paper. E power 4x times tan 4x plus secant square 4x dx. Answer, just that is, you mean to say evaluate. You can write evaluate. Now put 4x equal to t. 4 dx is equal to dt. My dx will become dt by 4. Therefore, integral 4x into tan 4x plus secant square 4x into dx will be written in terms of t as e power t tan t plus secant square t into dt by 4. 1 by 4 being a constant is taken out of the integral. 1 by 4 integral e power t into tan t plus secant square t dt, which is reduced to 1 by 4 e power t tan t plus c, since integral e power x into f of x plus f dash of x dx is equal to e power x. There is a simple proof you might have learned in integration, in fact. Now here, instead of e power x, I have e power t. Instead of f of t, I have tan t. Then the derivative, tan t derivative is there here. Therefore, this is nothing but 1 by 4 e power 4x into tan 4x plus c is the final answer. Let me just repeat once again. Put 4x equal to t. 4 dx equal to dt. dx is dt by 4. Now, the integral e power 4x tan 4x and secant square 4x dx becomes integral e power t tan t plus secant square t dt by 4. dx becomes dt by 4. 1 by 4 being a constant is taken out of the integral. 1 by 4 integral e power t tan t plus secant square t dt. It's to the form e power x f of x with f dash of x dx. This is e power x f of x. Sorry, I forgot to write f of x here. I'm sorry. Integral e power x and f of x f dash of x dx e power x f of x. Earlier I wrote simply e power x. Sorry. When I was explaining, I forgot to write f of x. Sorry. Now, instead of x, I have t here, e power t, and instead of f of t, I have tan t. Derivative tan t is secant square t. Now, 1 by 4 e power t tan t plus c is the final answer, but answer has to be in terms of the original variable x by which I started with. Now, for 1 by 4 e power 4x tan 4x plus c, and you can have a generalization in general. E power ax tan ax plus secant square ax dx will be automatically 1 by a e power ax tan ax plus c. You can have a generalization. A here is 4. You can have infinitely many values, real values for a. I hope it is easier for everybody to follow. The same method to be followed. Ax will be t, a dx is dt, dx is dt by a. Therefore, 1 by a is taken out. It's to the form e power t tan t plus secant square t dt. Now, for 1 by a e power t tan t you will get. Now, for 1 by a e power ax tan ax plus c. Here, the specific value for a is 4. So you can have a generalization also, which will be very helpful for you to do in a faster way in competitive examinations. In CBSE, you are supposed to, you can easily verify the final answer by remembering the rule which I told you just now. It's very easy, it's very simple. Okay, next problem goes like this. Find the unit vector perpendicular to a vector plus 2b vector and a vector, where a vector is I plus j plus k, b vector is 2i plus j plus k. Let me just show you the question. It's very big, therefore I am showing the question. Just read the question if you want. You can just read the question. Now, I am going to the answer directly. This is my 9th question. See here, I will call u vector as a vector plus 2b vector. What is my a vector? A vector is I plus j plus k, I plus j plus k. 2 into what is my b vector? 2i plus j plus k. Therefore, this is I plus 4i plus j plus 2j plus k plus 2k will be the reduction, which is pi I plus 3j plus 3k. Let it be. Now unit vector perpendicular to u vector comma a vector is given by plus or minus u cross a divided by mod u cross a. This is the formula to be used. Okay, I use plus or minus because it can be along the direction of u vector or along the direction of a vector. That is the meaning. The vector perpendicular to vector a vector b vector unit vector is given by plus or minus a vector b vector if it is given plus or minus a cross b by mod a cross b. That's what I am supposed to remember anyway. Instead of a, I have u vector which is a plus 2b here. Instead of b, I have a vector here. Remember carefully. Okay, because a cross b in general is modulus a vector, modulus b vector into sin theta into n cap, where theta is the angle between the directions of the two vectors and n cap is the unit vector perpendicular to both a and b in such a way that a vector, b vector, n cap form right-handed triad. It's what the formula you are supposed to remember. Now for mod a cross b is nothing but mod a mod b sin theta. Now for a cross b by mod a cross b, ab sin theta n cap by ab sin theta will give you n cap. But I used to write plus or minus because the direction can be either along a vector, a cross b vector, or along b cross c vector. Here u vector a vector, I said sorry. It's not along u vector a vector, I am sorry here. I said u vector a vector can be along u cross a or along a cross u also. Either way it can be. It can be in the opposite direction also. Now let me initially find u cross a, which is determinant I, j, k. Then components of u 5, 3, 3, then components of a 1, 1, 1. Here the determinant is I cap into 3 minus 3 minus j cap into 5 minus 3 plus k cap into 5 minus 3 again. And for this reduced to minus 2j plus 2k. Minus 2j plus 2k. And for modulus u cross a now becomes root of 4 plus 4. Which is 4 root 2. Therefore, required unit vector is equal to plus or minus minus 2j plus 2k divided by 2 root 2. Of course, it should be 2 root 2. It should be 2 root 2. Sorry, it should be 2 root 2. Root 4 is 2. Sorry, this 2 can be cancelled out. Now for plus or minus minus j plus k divided by root 2 divided by root 2 will be the final answer. Let me just repeat once again. I take a plus 2b as the u vector, I plus j plus k plus twice of 2i plus j plus k. Right, I plus 4i, j plus 2j, k plus 2k, 5i plus 3j plus 3k. Unit vector perpendicular u vector from a vector is given by plus or minus u cross a mod u cross a. I write it as plus or minus because it can be along u cross a or along a cross u in the opposite direction also. Okay, it is perpendicular, the plane containing both u and a, that's the meaning. Initially I said u and a, it is not ua. Along u cross a or along the opposite direction a cross u also. Now u cross a, determine the ijk, components of u 5, 3, 3, components of a 1, 1, 1. Now I cap into 3 minus 3. Minus j cap into 5 minus 3 plus k cap into 5 minus 3. Therefore, this is 0. 0 I need not write. Minus 2j plus 2k. Mod u cross a is root of minus 2 whole square plus 2 square. For 2 root 2. Sorry, root 4 is, that is, it will be root 8. Root 8 is nothing but 2 root 2. For required unit vector is plus or minus minus 2j plus 2k by 2 root 2. This 2 can be cancelled out. Plus or minus minus j plus k by root 2. If anybody leaves like this, that is also correct. It's not a major error. It's not a major error. That is also correct. That is also correct. It's not a big mistake. Just listen. Now, 10th problem. I'll just read out and show it to you. The 10th problem. Find the plane, equation of the plane passing through. Find the equation of the plane passing through 1, 1, 1, 0, minus 1, 2, 5, 0, 1. This is the question. Just see if you want. This is the question. This is the question shown to you, given to you. Now, in general, if a plane passes through three non-collinear points x1, y1, z1, x2, y2, z2, x3, y3, z3, the equation is given by determinant x minus x1, y minus y1, z minus z1. Second row will be x2 minus x1, y2 minus 1, z2 minus z1. Third row will be x3 minus x1, y3 minus 1, z3 minus z1 is equal to 0. That is what the formula to be followed. Now, equation of the plane passing through, okay, first point here is 1, 1, 1, comma 0, comma minus 1, comma 2, comma 5, comma 0, comma 1 is determinant x minus 1, y minus 1, z minus 1, 0 minus 1, minus 1, minus 1, 2 minus 1, then of course 5 minus 1, then 0 minus 1, 1 minus 1 is equal to 0, which implies, okay, determinant x minus 1, y minus 1, z minus 1. Here it is minus 1, minus 2, which is 1. Here of course 4 minus 1, which is 0, is equal to 0, which implies x minus 1 times 0 plus 1, minus of y minus 1 times 0 minus 4. Then of course plus z minus 1 times, you get it to be 1 plus 8 is equal to 0, 1 plus 8, which implies you end up with x minus 1 plus 4y minus 4, okay, then of course plus 8z minus 8, 9z minus 9, sorry, it is not 8z minus 8, 9z minus 9, 9z minus 9, sorry, 9z minus 9 is equal to 0, which implies x plus 4y plus 9z is equal to 14, is equal to 14. That will be the final answer. That will be the final answer. You can just check once again. I already told you, if plane passes through x1, y1, z1, x2, y2, z2, x3, y3, z3. Its equation is given by determinant x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus 1, z2 minus z1, x3 minus x1, y3 minus 1, z3 minus z1 is equal to 0. Here, instead of x1, y1, z1, I have 1, 1, 1. Instead of x2, y2, z2, I have 0, minus 1, 2. Instead of x3, y3, z3, I have 5, 0, 1. Now for x minus x1, x minus 1, y minus y1, y minus 1, z minus 1. 0 minus 1, minus 1, minus 1, 2 minus 1. 5 minus 1, 0 minus 1, 1 minus 1 is equal to 0. Determinant x minus 1, y minus 1, z minus 1, minus 1, minus 2, 1, 4, minus 1, 0. X minus 1 into remove the row column, 0 plus 1. Minus of y minus 1 into remove the row and column, 0 minus 4. Plus of z minus 1 into remove the row and column, 1 plus 8. Now for x minus 1, then of course plus 4y minus 4 plus 9z minus 9. X plus 4y plus 9 is equal to 14. Minus 5 minus 9 minus 14 taken to the other side becomes plus 14. This is anyway minus 4. Minus 4. This is the way it's being done. Okay. Section C will be discussed in the next video. Thank you students for patient watching.